10.1. In the diagram, triangle ABC is drawn. D is a point on AB and E is a point on AC such that DE is parallel to BC. BE and DC are drawn. So this is our proof question. Use the diagram to prove the theorem which states that a line drawn parallel to one side of the triangle divides the other two sides proportionally. In other words, prove that AD over DB is equal to AE over EC. So this is your proof from the geometry booklet. So what you need to do is firstly construct H1. So here we're going to do a few constructions here to solve this proof. And here we need to draw on either side here. So here is H1 and this will be a 90-degree angle. So H1 and H2. So H1 from E, and we just construct it first and then we'll say exactly what we're doing. So here H1 and H2. So once we construct that, let's actually make a note of that. So construct, draw H1 from E perpendicular to AD and draw H2 from D perpendicular to AE. Right? So they specifically have to be at 90 degrees. So H2 from D to AD. Okay, so then after that, let's just actually make a note here. So A1 is from E. So that's H1 here, and that's H2. Okay, so once we constructed, our proof itself is applying the area rule. So firstly, proof is the fact that we actually using a ratio between the two areas. We might need a bit more space here between the two. And if we have a look at the triangle ADE, and if you look at the triangle BDE, so let's just highlight these two here. So ADE, that's our main triangle here at the top. And thereafter, our other triangle we're looking at is BDE. So that's the first comparison or ratio we're looking at. And then in the next ratio, we will look at ADE and DEC. So we will have two ratios which are both equals to ADE. So firstly, first one here, area of triangle ADE divided by area of triangle BDE. And if we equate that, this is ADE is half base the height, so half AD and the height in this instance is H1, which we drew. So half AD times H1, and at the bottom is also the fact. So H1 would be the perpendicular height for both, because DBE extends the perpendicular height is also H1. So that's how that helps us here. So this would be half DB times H1. And then thereafter we can see the halves cancel out and the H1s cancel out. And what we left with is AD over DB. Then thereafter we need to go ahead and do the exact same calculation for triangle ADE and DEC. So again, area of triangle ADE. The only difference is this is from the other perspective, so our perpendicular height in this instance will be H2. Area of triangle DEC, and again this would be half AE, so it's from the other other base on the other side, since we're using DEC in this instance, H2 all over half EC times H2. So again, halves cancel out, H2's cancel out, and we're left with AE over EC. So thereafter, what we can also say is, or what we can conclude from this calculation is the fact that the area of triangle BDE is equals to the triangle, is equals to the area of the triangle DEC. And the reason for that is, well, they have the same base and the same height, the same base and height. Or the other reason, what we can also say is the fact that DE is parallel to BC. So that's the other reason. Or we can say, oh, DE is parallel to BC. And that is our reason as to why those areas are equal. So therefore, what we can say is that therefore area, and we can bring these two down because they are essentially equal now. So therefore, we can conclude that the area of ADE over the area of BDE is equals to the area of ADE over area of DEC. And if we take our ratios from what we concluded, therefore we can prove, and what we wanted to prove was AD over DB is equals to AE over EC. And that is exactly what we have here. EC.